Hey there, thanks for tuning in to Check This Out Mathematics, and I encourage you to like these videos and subscribe to my channel and make some comments down below and watch more videos so that I can bring you watch these videos more and so I can bring you more content. Alright, thank you. Alright, now in these series of videos we've been talking about formulas that generate Pythagorean triples and the underlying concepts. And so these are the three formulas that have been previously presented that generate Pythagorean triples. And we've discussed this first one here. And in this first formula that generates Pythagorean triples, we should notice that this is the type of triple where the C value is one more than the B value. And so that only generates a certain Pythagorean triples. And then here we have Euclid's formula for generating Pythagorean triples. And this gives us all the primitive Pythagorean triples that we have displayed in this illustration behind me. And we've talked about that particular formula already. And this is the third one that we're discussing now. And we've already done a previous video talking about some neat things about this formula that generates Pythagorean triples, and so I encourage you to go back and look at that one. And in this particular video, we're going to look at the expansion of this formula that generates Pythagorean triples. So the idea is that if we have S and a T value, where the S and T values are elements of the natural numbers, those are the counting numbers, and we have arranged the S and T values according to these three algebraic expressions, that this will give us A, B, and C values, where A squared plus B squared equals C squared. So we want to show that that's true, that if we take 2st plus 2s squared and substitute it in in place of A and square it, and then we take 2st plus t squared and we substitute it in place of B and square it, and we add those expressions together, we'll get this expression here squared for C, and it will all be equal. Okay, so let's do that. Okay, so now when we're going through this process, we're going to be using this general expansion that we talked about in previous videos, that x plus y squared gives us x squared plus 2x y plus y squared. And if you look at the distributive property here, you can see that that's true. All right, and so let's go ahead and go through the expansion for the A value. So looking at the value we have for A here, that is A is going to be 2st plus 2s squared. That's going to be our A value here, and we're going to square that. And so here's the 2st plus 2s squared, and we're going to square that. So that's our A squared expansion there. And again, we're using this idea here for our expansion. So being that the 2st is our x, we're going to have, this is going to be equals to 2st squared. So this is x plus y squared, and that gives us x squared. And then next we'll have plus 2xy. So that's plus 2, and then x is 2st times y, which is 2s squared. So here we have x squared plus 2xy, and then plus y squared. So that'll be plus parentheses 2s squared squared. Okay, so that's the y is 2s squared, and we're going to have plus y squared. Okay, so we use that general expansion. And now let's go through and multiply this out and see what we get here. So when we have 2st squared, that means the square goes to the 2 and to the s and to the t. So 2 squared is 4, and then we'll have s squared and t squared. So we'll have 4s squared t squared. And now going through this middle portion here, we have 2 times 2 is 4, times 2 is 8. And so that's plus 8. And then we'll have an s times s to the third, so that's 3 s's. So that's, s times s squared, which is s to the third. S times s times s, s to the third. Okay, and then you don't want to forget about t. T is a nice thing to have. And so there's t. All right, and now then plus 2s squared squared. So again, the 2 is being squared and the s squared is being squared. So that means 2 squared is 4. And when we have a power to a power, that means we're going to multiply them. So that's 4. 2 times 2 is 4 there, so that's 4s to the 4th. Plus 4s to the 4th. Okay. And so what we did here is we had 2s squared squared, so we multiplied it by itself, and that's 4s to the 4th. Okay, so that's our expansion for a squared. Okay, so let's put that aside and look at the b. Okay, so now here's our expression for b, and we're going to square that, so we have b squared. And so let's write that down. We have 2st plus t squared. 2st plus t squared squared. And that's our expansion for b. Okay, so now again using our general expansion here, we're going to say this is equal to the x again in this expression is 2st. So that's 2st squared plus 2 times x, which is 2st, times y, which is t squared. Okay, so we have our x expression here, 2st, and we have x squared, and then plus 2 times x and times y, so x squared plus 2xy, and then plus y squared. So plus t squared squared. All right, so that's our y squared. Okay, now let's simplify this. And again here, 2 squared is 4, and then we have s squared and t squared, so that gives us 4s squared t squared. Okay, and then we're going to multiply this through. So here we have 2 times 2, that's 4. And there's an s. And then t times t squared is t to the third. Okay, so let's see, that's 4s t to the third. All right, and then t squared squared, that's t to the fourth. Okay, and so now there's our expansion for b. Okay, let's put those two together on one slide. So we have a squared plus b squared, and that's the 2st plus 2s squared squared plus our b, which was 2st plus t squared squared. Okay, so we have a squared plus b squared, and this was our a expression squared plus our b expression squared. And when we did the a expression squared, we arrived at 4s squared t squared plus 8s to the third plus 4s to the fourth. And so that's like that. Let's write that down here. So 4s squared t squared plus 8s to the third t plus 4s to the fourth. Okay, so that's our a expansion there, as we had previously arrived. All right, and so now then let's go back to our b expression. We had 4st squared plus 4s to the third plus 4st to the third plus t to the fourth. And not really any like terms that I'm seeing. And so when we're kind of running out of room here, so we'll just put those down, plus 4, oh, hold on a second now. There is the b has a 4s squared t squared, and the a has a 4s squared t squared. Okay, so there's some like terms. Okay, all right. So let's write that underneath here. So we have plus 4s squared t squared, that's for b, plus 4, and these are not really like terms, so we're going to write them out to the side here, plus 4s t to the third plus t to the fourth. Okay, so when we did b squared, that's the 2st plus t squared squared, we got that lower slide there, 4s squared t squared plus 4s t to the third plus t to the fourth. And that's what I've written down here in the upper slide. And I just put the 4st squared underneath the previous 4st squared that we did get when we expanded a squared. And so now, maybe we can fit these all together here and say that this is equal to, and let's write them in order. So I think we'll start with the 4s to the 4th. So that's 4s to the 4th. And then the next highest exponent with an s in it is s to the 3rd here. So that's plus 8s to the 3rd t. And then we want our s squared. So we're going to combine these. That gives us 8. We have 4st. We have 4 things plus 4 more things. That's 8 things. So that's 8 s squared t squared plus 8 s squared t squared. And you see what's happening here is the s is diminishing, s to the 4th and s to the 3rd and s squared. And the t is being built up. Here there's no t, and then here's t, and then here's t to the 2nd. And so we want our t to the 3rd. So that's plus 4s t to the 3rd. And then now the s has completely diminished, and we have t to the 4th. So that's how we write them in descending order there, letting the s diminish and the t building up there. Okay, so that's our a squared plus b squared. And now we want to go through the expansion for c, and see that we get the same finished expression here. So we want to see that we get the same expression here. So we're going to box this in like a beautiful picture, picture frame around. Okay. All right, so now let's do the c part. Okay, so when we take a look at our expression here, this is the c expression, 2st plus 2s squared plus t squared. And we're going to put that in place of c and square it. So let's write that down. All right. So 2st plus 2s squared plus t squared squared. And this is our c squared. Okay, now we're going to use this same general expression here, expansion here for x and y. So x plus y squared will give us x squared plus 2xy plus y squared. And even though we have 3 terms here in the parentheses, we can think of it as 2 terms if we do a little grouping. So we're going to imagine this first group here, 2st plus 2s squared, as our x, and then t squared as our y. Okay. So we'll take the x expression and square it. So this is equal to 2st plus 2s squared. So that's the x expression squared. And then we want to say plus 2xy plus 2, and then the x expression 2st plus 2s squared, and then y t squared. Okay, so we have 2 and then x and then y, and now we're running out of room, so we'll drop it down a bit here, plus y squared, so that's plus t squared. Okay, so now in the previous problem here, we had this 2st plus 2s squared squared. That's this one right here. And so we already know what that gives us. It gives us this expression here. So let's go ahead and write that down. So we'll have 4s squared t squared plus 8s to the third t plus 4s to the fourth. Okay, so that's what we get when we take this expression here and square it. We get this one. Okay, and now then let's go through this here. We have 2t squared times this parentheses in the middle. So let's do that on another slide here. Okay, so we have 2 parentheses 2st plus plus 2s squared times t squared. Okay, and let's move the t squared next to the 2. So we have 2t squared and then 2st plus 2s squared. So we wrote the t squared here with the 2. And now then we're going to distribute. Okay, so 2t squared times 2st, 2t squared times 2st. All right, so then we get, that's 4st to the third. All right, 4st to the third. And then we want to distribute the 2t squared times the 2s squared. So that's 2t squared times 2s squared. And so that'll give us 2 times 2 is 4s squared t squared. Plus 4s squared t squared. Okay, so that's our expansion here. And so going back, running out of room to put all these slides. Okay. All right. No, that's not one. Yes, this is one. Okay. So we did the x squared. So there's x squared, and that gave us this expression. And then we did the 2xy, which we, here was the x squared. No, that's not it. That's, yes. This was the x squared. So we wrote that down there. And then we did the 2xy. Oh yeah, that's this one here. So yeah, did need to come back to this. There's the 2xy. Okay, so let's write that down. So we have plus 4s t to the third and plus 4s squared t squared. Okay. All right. And then plus the y squared, that's t squared squared, that's t to the fourth. All right. Goodness, there ought to be a way to. This Mr. O'Donnell writes too big and the slides are too small here. Okay, well anyway, let's see if there's any like terms here. So we have s to the third t. Nope, there's not any more of those. Okay, that looks to be it there. Okay, so what we're going to do there is put the plus t to the plus t to the fourth. Up above there. So we'll improvise, right? Okay. And so now let's again write this in descending order and try to fit it all together on one line here. Okay, so we want the 4 equals 4s to the fourth, and then the s to the third term, that's 8s to the third t, and then the s squared term. Oh yeah, we have some s squareds. Okay, that's why it's hard to write it on the one line. Here we have 4s squared t squared and another 4s t squared. I think that kind of was happening before. Maybe you have a deja vu like I have here. Okay, so that's 8s squared t squared. Okay, so we're writing this expansion here in exponential order here. Exponential order? In standard, in the order from the exponents diminishing and the other exponents being increased there. Okay, whatever you should call it. Okay, so s to the fourth, s to the third, and s squared. The s is diminishing in the powers, and the t is building up. Here's no t, and here's t, and here's t squared. And so then plus, we want to look for just the s term. So there's 4s t to the third. Okay. And then plus 4st to the third. And then we want to not have any more s's and just have t. Okay. So the s is diminished, t to the s to the fourth, to the third, to the second, to the first, and no s. And the t is being built up here. no t, t squared, t to the third, and t to the fourth. And that's how we write algebraic expressions in standard form there. And let's box that in here, because I think we've done it, haven't we? Yeah. So here's a squared plus b squared, and you can have that boxed in expression there. And then here's c squared, and what do you think? They look alike? Yeah, they're the same. Isn't that awesome? Okay, so we have shown that this formula for generating Pythagorean triples is in fact a solution to the Pythagorean theorem, that a squared plus b squared equals a c squared if we take a as 2st plus 2s squared and square that, and then take b as 2st plus t squared and square that, and then we when we add them together, we get this expression here on this slide that's kind of wavy, and now then that gives us our c squared, and you can see that the c squared is the same as the a squared plus b squared. All right. Okay, pretty cool. So now we have done what we set out to do, that this formula that generates Pythagorean triples is in fact a formula that does generate Pythagorean triples because it is a solution to the Pythagorean theorem. Okay. And so in the next video, we're going to show how did this formula come about. All right, and that's really the inspiration for doing all of these videos that have been presented, that with this formula that generates Pythagorean triples, and this illustration of all the Pythagorean triples where the a, b, and c value are less than 100. Those are the two inspirations for doing all of these videos here. So we're going to finish it off. You know, we finished off the first series of videos with showing this inspiration here. That was the first 5 videos. And then these last 5 or 6 videos, we're going to show where this formula for generating Pythagorean triples came about. And so we'll finish off with that, because that was the other inspiration. Okay, so this is getting exciting, right? Okay, yeah. All right, so thanks for tuning in to Check This Out Mathematics, and I encourage you to like these videos and subscribe to the channel and make some comments, and watch all the videos and watch them more, and that way I can keep bringing you content. We're going to bring a lot of interesting content on this Check This Out Mathematics. Cool stuff. Okay, Mr. Dahl signing off.